Everyone, hope all is well. So today we're going to review a little bit what we've talked about with polygons and interior and exterior angles. So we're going to do a few examples. It says name the regular polygon with an interior angle measure of 135. So a couple ways we can do this, but I think the easiest is to remember the relationship between interior and exterior angles, which is that they add and combine to make 180 degrees. And to remind yourself of that, let's just quickly draw a hexagon. And you can see that if we look at one of the interior angles and its exterior angle, which would be here, they add together to make a straight line, which is why the interior angle and the exterior angle add to 180, because the line adds to 180. So with that in mind, if we have an interior angle that's 135, if we do 180 minus 135, we get 45 degrees for each exterior angle. And then if you recall, if you do 360 divided by n, the number of sides for a polygon, it gives you the measure of each exterior angle. So then if we do the reverse, if we do 360 divided by 45, that would give us the number of sides for the polygon. So 360 divided by 45, we get 8. So that's the number of sides. So an 8-sided polygon would be an octagon. Another example. So this one's a little bit trickier. We did this a good amount when we were in school with regards to it's a paragraph and we want to transform it into a math type equation. So it says the measure of an interior angle of a regular polygon is 36 more than 3 times the measure of one of the polygon's exterior angles. How many sides does the polygon have and what is its name? So it seems like a lot to begin with, but let's think about measure of an interior angle. So let's call that x. Then we're just going to read the paragraph and build our math sentence from left to right. So the measure of an interior angle x of a regular polygon is, so x is 36 more than, so 36 plus 3 times the measure of one of the polygon's exterior angles. So if x is the interior angle and it's 3 times the measure of its exterior angle, well, the exterior angle is just going to be 180 minus the interior angle x, right? Because in the previous slide, that's what we talked about. Interior angles and exterior angles add to 180. So then we just go ahead and solve this equation, distribute the 3 to the 180, we get 540, and then minus 3x. And then if we add 3x to both sides, we get 4x equals 36 plus 540. So 4x equals, let's add those together. We get 576. Divide by 4. We get 144. Now remember, we named x as the measure of its interior angle. So if I do 180 minus 144, let's see what we get. We get 36 degrees. So 36 is the measure of each exterior angle. And then just like the previous slide, if we do 360 divided by that 36, we would get the number of sides, which would be in this case 10. So a 10-sided figure is a decagon. So the answer to the question, how many sides? 10, and we call that a decagon. Now, if you recall, with interior angles, the interior angle sum of any polygon is n minus 2 times 180, where n is the number of sides, right? So let's say I have 10 sides, 10 minus 2 times 180. That total is going to give you the total for the interior angle sum. Now, I think it's easier to relate it to the exterior angles like we did here. This is a perfectly fine way to do it to get to your answer of 10 sides and that it's a decagon. But this is another way you can do it, but I'm trying to use as little formulas as we need to answer the question. As always, reach out if you have any questions.